Assalamualaikum warahmatullahi wabarakatuh. We are for Group 7. We will present for group project for ITT640 Wireless Local Area Network. So this is our team member, lead by Syabin Akiuddin bin Shalizam, followed by Muhammad Zikri Iman bin Muhammad Saleh, and me, Muhammad Syafiq bin Abu Bakar. So for introduction, the company for the company background, the organization has the building with 3 story. In this organization, there are no workers that work remotely, and the organization has several departments, which is information technology department, research and development department, shipping receiving department, manufacturing department, and sales department. For the project background, the business has 3 floors, which is 3 floors. The first floor is for the ground floor, shipping receiving department, manufacturing department, and sales department. For the first floor, information technology department and research and development department. For the second floor, there is a administrative office, finance office. So for this problem statement, there is limited network diagram. The wireless access point is overlap, and the wireless standard were outdated. So the objective for the project is to design the wireless network for small company with 3-story building using simulation software, and analyze the wireless technology presented in wireless network. So for literature review, we have wireless local area network definition and wireless standard. So for the WLAN definition, WLAN is a wireless local area network. So wireless local area network will send data between computer using radio frequency or an infrared to communicate between the computer. This technology excel in transferring data across barrier or building without the use of cable, because WLAN has same quality as LAN. Many devices are designed to support wireless local area network. So for the standard, there is 802.11b, which is developed in July 1999 as expansion of previous 802.11 standard. The 11 Mbps of bandwidth supported by 802.11b is comparable to that of conventional internet. Originally, 802.11 standard and 802.11b both use the same unlicensed radio transmission frequency, 2.4 GHz. In order to reduce their production cost, vendor frequently favor using this frequency due to its lack of regulation. So next is 802.11g, which is more recent from the 802.11b. It appeared on market in 2002 and 2003. The maximum bandwidth capacity is 54 Mbps, 54 megabit per second, and 2.4 GHz of frequency. It also offer a longer range because 802.11g and 802.11b are backward compatible. 802.11g access point can be used with 802.11b wireless network adapter and vice versa. Next is 802.11n. The Institute of Electrical and Electronics Engineer created the wireless networking standard. 2 key components are an access point which acts as conduit for wireless signal between user and router, which link each access point to the client device. The feature of IEEE 802.11n is that it operates at frequency of 2.4 GHz and 5 GHz with maximum data transfer rate of 300 megabit per second. Its transmission distance is 250 meter in an open environment and 70 meters in an open structure. It can cancel out any external noises, and it is compatible with IEEE 802.11b and IEEE 802.11g devices. So next wireless standard is 802.11ac. In 1997, the IEEE 802.11ac wireless networking standard was released. The widespread use of portable computer such as smartphone, laptops and tablets, as well as entertainment system such as television and video game console, has had impact on gigabit Wi-Fi. The development of technology that's allow high definition video streaming, which consume a lot of bandwidth for HD video, is influenced by how well a technology is received, because it is dependable quality and data transfer capability. IEEE 802.11ac priority will continue to rise in the near future. So next wireless standard is 802.11ax. The benefit of this wireless standard is include increase network capacity, improve the performance, lower latency, and higher efficiency. This new protocol main goal is to put in place innovative technique to serve more consumer with dependable and consistent data flows in an effort to boost throughput.
Assalamualaikum warahmatullahi wabarakatuh. So this for the proposed network requirement. On the ground floor, there will be 4 access points. The ping round trip at most is 30 ns and the packet loss at most is 1%. On the first floor, there will be 3 access points. Ping round trip at most will be 30 ns and packet loss is also at 1%. Second floor, there will be 3 access points. Ping round trip at most is 30 ns and packet loss at most is also 1%. Ground floor and second floor will have the same signal strength, which is negative 65 dBm. Then signal to noise ratio at least will also be the same, ground floor and second floor, on 40 dB, and the data rate will be 50 Mbps, while on the first floor, signal strength is negative 70 dBm, signal to noise ratio is will be 30, and the data rate will be 25 Mbps because there's lower client than ground floor and second floor. So next, this is the proposed physical topology. On ground floor, as you can see, there is 4 access points. Each access point on each room, and on the first floor there will be 3 access points, access point 5, 6 and 7. R&D department will have 2 access points due to its size, to ensure there is no dead zone, so that the client can connect to the internet. The third one is second floor. Access point 8 will fulfill the need of finance office, while access point 9 and 10 will ensure that there is connectivity in general manager office, assistant general manager, human resource manager, and administrative office. On this part, there will be only 2 access points, which is access point 9 and 10, as because that if there is, say, there are for access point in that particular area, there will be network congestion. So here, the next part is the wireless access point information. We'll be using the Cisco AeroNet 4800 access point series. The access point can support up to 200 clients, but estimated around 50 devices can connect to it. Multi-gigabit Ethernet support will be on 100 Mbps. The standard that this access point use is 802.11 AC or Wi-Fi 5. Authentication and security, this access point uses WPA 2PSK, while the authentication is encryption AES. There is the software that you can use in order to configure this access point, which is the Cisco Unified Wireless Network software, Cisco Mobility, and lastly Cisco Data Assurance Active Sensor. The, the frequency that this access point supports is 2.4 for devices that are far much away from the access point, and 5 GHz for those that are near the access point. The range for this access point is around 100 meters. So next one is the signal strength and coverage. After applying the access point inside the office, as you can see that uh, the access point covers all of the room of the area of the office. There are no dead zone. Same goes for the second floor.
So this is the network topology for the proposed network. So first of all, on the left side, which is in the blue rectangle, is the ground floor, and then on the green rectangle is the first floor, and the last one, the second floor, is on the yellow rectangle. So first of all, on this network topology, we have one router that is located on the wiring closet on the ground floor. So this router will connected to three switch 1, switch 2, and switch 3. So the switch 1 is the switch for the ground floor, switch 2 is the switch for the first floor, and the switch 3 is the switch for the second floor. The router is connected to all switch via fiber. Okay, next we will see to the ground floor. So on the ground floor we have 4 access points, which is AP1, AP2, AP3, and AP4. AP1 is for the shipping department, AP2 is for the sales department, AP3 is for manufacturing department, and the last one, AP4, is for the conference room. So we will move on to the first floor. So on the first floor, here we can see that there are 3 access points. For the AP5, access point 5 is located at the IT department, and while AP6 and AP7, both of them is used for R&D department. Next, we'll move on to the second floor. So for the second floor, there are 3 access points. Also, for the AP8 is for the finance office, and AP9 and AP10, both of them is for administrative office. So, so let's go. We will try ping the device between the floor. So I want to say, please take note that on this network topology, we will only simulate several devices, not all the device. So first of all, I will ping from the ground floor to the second floor. So here we will go to desktop command prompt, and here first of all I will try to ping the default gateway of the ground floor 1.1.1. So we can see that it is successful. Next, we will try to ping the device on the first floor. So ping, we will take the laptop 4, which is IP address 192.168.2.4. So we can see here that so it is successful. Next, we try to ping on the second floor. So here we try to see that we will ping on the we will try the PC2, which is ping 192.168.3.9. So wait, we will wait for the minute. So we can see here that the ping is successful. So we will try to ping from the first floor to the other floor. Wait, we will try to use the laptop tree, and then we'll ping. So first of all, we will ping the device on the same floor, which is 192.168.2.3. So it looks like there are some problem. So wait a minute, we'll see. Oh, sorry, there are different IP address. Okay, we try ping back. So here we can see that it is successful. Next, we will ping to the first floor, which is laptop. We will ping the laptop 10, laptop 0, 192.168.1.6, and we will wait for a minute. For a moment, we can see that it is successful. Next, we will also ping to the second floor, which is on the PC2, 192.168.3.9, and it is successful. So next, we will try to ping from the second floor to other floor. So we will take the laptop file, desktop, and the command prompt. First of all, we try to ping the device on the same floor, 6x23.9, and it is successful. Next, we will try to ping with the other floor, which is ground floor, 192.168.1.3, and for the last one, we will ping on the first floor, ping 192.168.2.7. So we can see here that all of the ping is successful. So we can conclude that uh, the connection between the floor is established.
We will be going to Zikriman and present about the network solution demo. Next. Result and analysis. So after conducting the experiment inside the packet tracer, each floor there will be 3 tests at range of 10 seconds. The devices from ground floor to another device from ground floor have an average of latency of 38 ms, jitter of 10.78 ms, and 0 packet loss. Ground floor and first floor, 26 ms, 6.5 ms, 10% packet loss. The ground floor to second floor will be 26 ms, 4 ms on jitter, and 10% packet loss. While on the first floor to first floor, another device on the first floor is 30 ms, 2.6 ms on jitter, and 0% packet loss. Devices from first floor to ground floor will be on the latency 35 ms, jitter will be 7.1 ms, and packet loss is 0. First floor to second floor is 27 ms on latency, 11 ms on jitter, and 0 packet loss. Second floor to second floor, which is the 2 devices connected on the same floor, 31 ms on latency, 4.8 ms on jitter, packet loss is 0. Second floor to ground floor 25 ms, jitter 10 ms, and packet loss is 0. And the last is second floor to first floor 27 ms on the latency, 8.8 ms on jitter, and the last is packet loss, which is also 0%. So that is all from us. Thank you.